Hello everyone, my name is Lorena Cruz and I will present a summary of the work entitled Hybrid Matrix of Silicon Dioxide plus PMMA doped with luminescent nanoparticles of gadolinium oxide and europium, synthesized on optical proprietors, in collaboration with the doctors Juan de la Cruz Quiroga, Rodolfo Palomino Merino, José Eduardo Espinosa Rosales, and Ricardo Agustín Serrano. The luminescent gadolinium oxide nanoparticles doped with europium were synthesized by the precipitation reaction using gadolinium and europium nitrates as precursors. And these resulting solution nanoparticles were introduced in a hybrid silicon dioxide plus PMMA matrix synthesized by the simultaneous hydrolysis of tetraethyl orthosilicate and the polymerization of the methyl methacrylate. This hybrid matrix was chosen due to the high transparency and improved mechanical properties over a simple dioxide matrix. Also, this allows for an easy doping of the material and the fabrication of thin films and monoliths with possible optical applications. The gadolinium oxide has attracted a great deal of interest because it had unique properties which make it useful in various technological applications. For example, it possesses a high transmission in the visible region of the electromagnetic spectrum, broadband gaps, and other characteristics. By the other hand, the hybrid materials and the nanocomposites are materials formed by several components joined at nanometer or molecular level. And it has been observed that these types of materials exhibit improved mechanical properties better with respect to their individual components. It's also possible to adjust several of these properties by changing the proportions and the composition of their components, such as their optical and electrical properties. And it has been observed that certain phosphors maintain their luminescent properties while gaining photostability when we incorporate it into this type of materials. In the experimentation, we synthesized the nanoparticles by a precipitation reaction in an aqueous solution with a europium concentration with gadolinium nitrate extract, and we use as a solvent distilled water. We also use ammonium hydroxide as an agent to start the reaction in this aqueous medium. On the other hand, for the hybrid matrix, we synthesized by the Soljock technique by the simultaneous hydrolysis of tetraethyl orthosilicate and the polymerization of methyl methacrylate in an ethanol solution. We use also other components to start the polymerization of the methyl methacrylate, that is the benzoyl peroxide. We use an agent to binding the silicon and the PMMA, and we also use sodium hydroxide to control the acidity of our solution. Also, since the stage of the Soljock process are slow, it is possible to add doping agents, in this case the nanoparticles, so that they remain encapsulated due to the aging time and the subsequent evaporation of all the solvents. Once the gel is dry, the result is a small tablet that precipitates the nanoparticles on one of his faces and presents a good luminescence under UV excitation. The color is between red and orange and can be corroborated thanks to the chromaticity diagrams and the photos presented in this work. And finally, the characterization carried out are presented, which are Raman, SEM, UVBs, emission and excitation, and the AFM.